Hello, everyone. Thank you for joining us. Thank you for joining our session. My name is Michalis Petropoulos. I'm Director of Engineering for Amazon Redshift. And with me, I have Errol Güni from Workday, who's going to talk to us about data as a service and how Redshift powers his application. I've been with AWS for 4.5 years now, and I've been building database systems my entire life, professional life. And I'm here to explain to you, to help you, give you the information you need to make your decision about your Redshift footprint. First, I would like to start with a brief journey back in time. 7 years ago, it was reInvent 2012. You can see here relatively younger Andy Jassy, describing the tenets of a data warehouse built by AWS. At the time, the tenets were, of course, revolutionary because he was talking about a data warehouse that was easy to use and spin up. It was also easy to scale up massively in terms of compute and storage. It was also very cost-effective. We didn't have any upfront costs. You were just paying as you go. It was also very performant. It had to be performant for the price that you're paying. At the time, he promised less than $1,000 per terabyte per year, which was, of course, much, much cheaper than the other options at the time. And the last tenet had to do with being open and flexible to be used with other tools, either to load data into Redshift or visualize data outside of Redshift. So he announced Amazon Redshift 7 years ago, and the service today the service at the time became the fastest growing service until 2016, for 4 years, until we announced Amazon Aurora. So today, Amazon Redshift is being used by tens of thousands of customers. It is the most popular cloud data warehouse, and it's also the fastest data warehouse. You can see some of the customers, some of the prominent customers that are using our service today. So the tenets that Andy described 7 years ago have not really changed much since then. So we're still trying to build a service that is very performant, very cost-effective, very scalable, and very easy to use. So how do we keep innovating at this pace, and how do we keep expanding the service in a way that accommodates new use cases? We do that by pretty much listening to customers, listening to your requests. And what we have been hearing is that folks today, customers today, they like to make sure that their migrations of their on-premise systems to the cloud that are being done cheaply, fast, and without too much effort or incompatibilities. So, as you probably heard from Andy Jassy's keynote earlier, still the majority of the IT has not moved to the cloud, but we see that many major companies are actually over the tipping point of trying to decide whether they're going to move to the cloud, but more in the phase that says, how fast can we move to the cloud? So it is paramount for us to make it easy to customers in order to execute these migrations. The second set of requests that we're hearing is that there is data explosion primarily due to operational data. So the data warehouses and the operational data or operational analytics use cases, they are being blurred. So we see, for example, that the ingestion rate of customers in our fleet is much more frequent than it used to be. So over the years, we see that our customers typically ingest within a period of minutes or seconds. So we need to be able to accommodate this rate of ingestion as well as the volume of data that is being ingested into the system as well. And the last set of requests have to do with the end-to-end insights, which means that you don't only want to have analytics on your data warehouse, but you also want to have analytics on your real-time data as well as your historical data. So you don't need to choose between the two or wait or have different infrastructure for one nature of data over the other. So have the ability to reach over to any data that you might need to do your analysis. So especially for the last part, when we're talking about having the ability to reach to more data, what the approach that Redshift is taking is actually being fully integrated with a data lake. So the data lake is here to stay, and Redshift is the only product that actually is fully integrated with a lake, meaning that you can actually ingest data into Redshift if you want to, but also you can actually operate directly on lake data without having to ingest into the system. This is unique to Redshift. You can run queries that join data within Redshift and open file formats in S3 and analyze your data, okay? Without waiting for the data to be ingested into Redshift before you can act on them. And vice versa, Redshift also exports data into the lake, as I will show you a little bit later, in such a way so that Redshift is not a closed system. So you can export Redshift data into the lake so that other systems, other services within the AWS ecosystem can act on them. So we do that, of course, through lake formation, and we're tightly integrated to lake formation in order to have very tight access control as well. So all of this loop that you see here is secure as well. Given that we're also merging or blurring the lines between the data lake and the data warehouse, we're calling this particular architecture that we're implementing lake house approach. So you don't have to choose between the two. All right. So here are today's version of the tenets that Andy talked about 7 years ago, most of which remain the same as I mentioned. So the first one is the data lake and AWS integrated. So I'll show you how we integrate with lake formation, and then a little bit later on, I will also show you how we reach into operational data. How do we actually go and query operational data in Aurora Postgres and RDS Postgres in place without having to ingest data. Best performance, we remain 3x faster than any other data warehouse. Lowest cost, up to 75% lowest cost than competitors. Most scalable, both in terms of storage and compute, and I will explain how we manage this with the new instance that Andy Jassy announced earlier this morning. Most secure and compliant, of course, this is always top priority at AWS, right? No matter what. And we're also fully managed. We will show you how we optimize the cluster using machine learning and without any human intervention as well. All right, so I'm going to dig a little bit deeper into 3 of these areas, in particular the performance and scalability, the fully managed, and the data lake integration, and pick a few features. Because in reality, we developed more than 200 features and enhancements in the last 18 months. So we're trying really hard to keep the rate of innovation high and to deliver value to customers as soon as possible. All right, so looking into specific 3 areas, on the left-hand side, you can see that I'm talking about performance and scalability. That's the first row. Data lake and the AWS integration is the second row, and the fully managed efforts are the last row. I'll give you a few seconds to scan this slide. I'm going to present it towards the end as well. But I am still going to focus on some of them. The good thing about having tens of thousands of customers is that we have many heterogeneous customers, so many diverse use cases. So we have to cater, of course, to all of them, and some of these features might apply to your use case more than others. But I'll focus a little bit on the major ones that might affect your bottom line or performance the most. So the first one that I'm going to talk about is the new instance that we announced today, RA3, with Amazon Redshift managed storage. So let's see what this means. So on the left-hand side, I show the data in the warehouse, actually data that are being ingested into a data warehouse. This is the blue line that you see. And then I also show you the yellow line, which is the enterprise data that might land in one storage system or another. So, of course, having the ability to scale compute and storage separately is very beneficial here because you want to have access to all enterprise data at all times, but you don't query them necessarily all the time, right? So you scale your storage so that you can fit all the data of interest, and you scale your compute in order to make sure that the most important queries run fast. So we achieve this with the new instance that we released, and the way we're doing this is that we're now having the Redshift cluster that you see on the right side operating on a Redshift managed storage layer. If you're wondering, this managed storage layer that we're using right now is S3, but of course, this is transparent to you. You don't have to worry about where we keep the data. In addition to the managed storage layer, we also have the yellow caches that you see right next to the compute nodes that you buy, the RA3 nodes. And we automatically, out of your entire data set, we intelligently identify, based on your query patterns, which data is hot, and we bring the data close to compute. So the most frequently accessed data are close to the compute, and your queries run fast. And when I'm talking about bringing the data close to compute, we're being very selective. So the granularity is not, for example, a table or a column or a set of rows, but it is specific columns of specific rows that we cache, which makes the whole system very flexible. So we are identifying with high precision the hot data, and we bring it close to compute. We're also changing, based on this instance, we're changing the billing model. So you pay separately for compute and storage. And it is fully automatic to you, so you don't have to decide which data is hot, which stays in the cluster, and which doesn't. This is fully managed within the service. And in addition to the new instance, or because of the new instance, we have very fast network access or network connection between the compute nodes and the Redshift managed storage. So whenever you're querying data that are not very close to compute, you don't fall off a cliff. So the query that needs data not cached is going to run a little bit longer, but there isn't going to be a big difference between the two. All right. So talk a little bit about pricing. So the on-demand price is $13.04 per node per hour. And for storage, you pay 24 cents per gigabyte per month. Okay? So, and it can scale into tens of petabytes. This is pretty much the vast majority of the use cases that we see today. They are covered by this limit. All right, so these instances, they are very well suited, in particular for current customers that are using dense storage 2 8XL nodes, DS2 8XL nodes. Customers see today up to 2x the performance and 2x the storage capacity for the exact same price. So we made sure that we're implementing this particular instance to make it a no-brainer to move your use case where you have a lot of data from current instances to the new RA3. So same cost, up to 2x performance, 2x storage capacity. All right? We still have the 3x price to performance ratio compared to any other data warehouse. And even the smallest instance, the smallest cluster that you can instantiate with an RA3, it can hold up to 120 terabytes compressed. So the starting point is also very economic. These are 3 quotes from customers that have already tried the new instance. And you can, within the text, you can identify a little bit of different use cases. Some of them, they wanted to fit more data into the cluster and make sure that the hot data remains close to compute. Others that were just looking purely for performance improvement, and all 3 got both. So performance improvement, higher capacity, same cost. And of course, you are free to choose lower cost for same performance. So we also give you the ability to choose between the 2, right? All right, so this is a major effort for us because now it enables the customers to really decouple the 2 and have the ability to scale them separately. So a big deal in terms of performance as well as storage scalability. All right. The next big announcement this morning that Andy Justy mentioned was AQUA. So AQUA is what we're doing to pretty much achieve a 10x improvement in terms of price to performance ratio. So the RA3 is the 2x that we have delivered today, and AQUA is in preview, and it will deliver a 10x in total in terms of price to performance ratio. Of course, this is working under the covers, fully managed. You don't have to do anything. And the way that we're doing this is that we're putting the AQUA layer between the Redshift cluster and the S3, and we embed the AQUA nodes, as you can see on the left, within the common Redshift managed storage layer. And what exactly is AQUA? AQUA is a very fast processing layer. It is a set of nodes that allow us to push compute very close to the data. So we pretty much decouple compute in this case, and we're saying that whenever we're executing queries, before we actually put any data on the network, we are going to apply filters, projections, and other things that will cut the amount of data that we need to pass over the network. So it's first of its kind. It uses custom hardware developed by us, and it's going to give us the next big wave in terms of price to performance improvements. All right. The third part that we announced recently is the new encoding, AZ64. This is the new compression encoding, and this is part of both the performance efforts as well as the fully managed. You don't really need to choose encoding anymore, because the nice property of AZ64 is that it achieves great savings instead of storage footprint, as well as performance. You can see on the right-hand side the comparison with other popular encodings, raw, LZO, and Z-standard, and you can see that AZ64 hits it right in the middle. So it has the footprint of Z-standard, which is very effective in compression, and it's faster even than raw. At this point, we are providing the AZ64 for numeric and date-time data types, but of course, the AZ64 for character columns is coming soon. All right. So AZ64 encoding, as I mentioned a moment ago, is part of our effort to improve performance. And especially we focused last year on the out-of-the-box performance. So without any tuning, how are we going to make the system perform? Without having to choose short keys or disk keys or any of that, how do we make the system performant. So what we managed to do year over year, as you can see here, it's actually not even year over year, is from June 19th to November 19th, we managed to get a 2.35x speed up out of the box. Okay? So when we're creating tables, there is no choice of encoding, there is no choice of distribution or sort key, there is nothing. We just create the table without any options, and we insert data. That's it. So apart from the AZ64 encoding, you can see in the list other efforts that we implemented that all of which you get for free. Bloom filters is one of them for both collocated and distributed joins, again, to reduce the amount of data that we put over the network. Enhanced query planner for modern CPUs. So we are making the plans, we tune the cost model so that we produce plans that benefit the specific cluster size. We're using hyperlog statistics in order to more accurately estimate the number of distinct values that affects whether a join is going to be distributed on both sides or one of them. We're also optimizing aggregations and joins in terms of cache hits and misses in order to accelerate such queries, which are common, of course, on Redshift. All right. So the last, next to last actually, feature that I'm going to talk about is Materialized Views. So Materialized Views is, of course, a well-known concept within data warehouses, especially valuable for use cases where you have fast ingestion and you have tens or hundreds of users accessing the newly ingested data on top of the system, right? So the big deal here is that as data come in, you update the materialized view once, and it's being queried hundreds of times. And of course, the materialized view, being able to materialize joins, filters, and aggregations, provides orders of magnitudes improvement over executing the query on base tables. This feature targets specifically the dashboard use cases, where a lot of users are executing the exact same query, right? So the nice thing about materialized views is that they're incrementally refreshed, meaning that if you're just adding a few more rows to your fact table every minute or every few seconds, then we're going to use only that data in order to update the view. We don't recompute the entire view, right? But on the other hand, it is user-triggered at this point. So you choose when to refresh the view. If you want to refresh it right after every ingestion, you can do that. If you want to refresh the view once a day or once an hour or once a minute, you can do that as well. So it's up to you of how many materialized views do you want to have, and how often do you need to refresh them based on your business needs, right? So it's very flexible. Of course, it also makes it faster to migrate into Redshift because traditional database systems, on-premise systems, users, customers have been using materialized views. All right. The next one is the support for spatial data. So we have introduced some well-known geometry data types. So it's actually one geometry data type that you can be specialized into multi-point, multi-line string, multi-polygon, and so on. At this point, we have implemented about a little bit more than 40 functions that will let you ingest data and manipulate data. And on the right-hand side, you can see a nice visualization of Airbnb locations in Berlin. And the heat map that you see there shows the density of the Airbnb offerings. If you're wondering how a query looks like, this is the same query pretty much, but here we display the points individually. You can see at the bottom there that we're using functions such as st-within, which are well known from the post-GIS lingo. So we're making sure that each shape stored in Redshift, which is pretty much a point of an Airbnb offering, is within a particular polygon. Okay. And the last one, in terms of performance and scalability that I want to talk about, is concurrency scaling. This is a feature that we announced last re:Invent with GA'd end of March. And of course, we have continuously been improving this feature. And the way it looks today, you can see on the right-hand side here, is that we can actually scale up to more than 12,000 queries per hour using 220 concurrent sessions. Now, of course, somebody might say that in OLTP systems, these numbers are per second, not per hour. But remember that the workload that we're talking about here is very similar to TPC-DS. So we're talking about heavy join queries here, okay? So the important thing is that we don't only reach the number that you see there, which is a significant throughput, but we also reach it linearly. So as you are adding more and more clusters, concurrency scaling clusters, you actually get almost linear increase in your throughput. And remember that concurrency scaling, when you enable it, you just choose how many clusters you want to engage, and the system engages the clusters automatically and disengages the clusters automatically based on the workload. You only pay for the time that you're actually using the cluster, running a query, not being attached. And for the majority of our customers, 97% of them, the 1 hour free, the free 1 hour a day that we're offering is sufficient. Okay, so I'll move on. I'd like to move a little bit on the data lake and the AWS integration and focus a little bit on the initial tenet that I mentioned about the openness of Redshift and the data warehouse scenario, and talk a little bit about the federated query. So in particular, what is amazing about this feature is that you can see on the right-hand side that you can actually access open file format data in S3 that landed there using any of the AWS services, right? Kinesis, Kafka, anything you can think of. You can query the Aurora Postgres SQL data. This is your operational data store, right? Or the RDS Postgres SQL, and join the data or union the data with your Redshift ingested data in one statement, right? So this opens many different possibilities, right? You can think, for instance, that you can have a query like this. On the left-hand side, you can see there that you have a data set in S3. These are line items. You have data in the public schema within Redshift, and you have data within the APG. This is the Aurora Postgres within line item. And you create a view that unions all this data. And then all of a sudden, you can write a query that you can see on the right side that spans 3 different data stores in one shot, right? So this is very flexible and very open because you can now have access to real-time data, really. And you can choose to ingest the data at a different frequency, potentially, than having to ingest the operational data into the warehouse in order to operate on the data. So this is pretty significant, and of course it makes it also easy to move data, to ingest data from the operational store into Redshift. This is yet another query, right? It also allows you to do analytics on your operational store, if you think about it. You can have, let's say, 3 Aurora databases, and you would like to execute a query across all 3 of them and create a report. You can do that too. You don't have to have Redshift data. Redshift is a very performant, massively parallel engine that you can use it with data only in one of the stores, right? Okay, so this feature is also in preview. You can actually see on our website in the What's New how to get your hands on the build that actually has this feature and try it out for your use case. All right. I'll talk a little bit about the data lake export in Parquet, again, referring to the lake house case where we access data within S3 without having to ingest, and having the ability to actually create tables in S3, create data in S3 in Parquet format so that other services within AWS can act on the data. Still, this is another effort of Redshift being an open system. So you can see here the actual command on the right side. You can say unload a SQL query to this particular S3 bucket. The format is Parquet, and you can also partition it by a specific column. And we will automatically generate the partitions and put the files in the appropriate buckets. Remember that the query that you can put under unload, it can still point to any storage system. I mean, you can use Redshift, for example, to do some ETL from S3 to S3. So you can say unload, select star from a table in S3, do some transformation in the select clause, and then output it again into S3. Again, you're getting the benefit of Redshift being a very performant engine without necessarily having to ingest data into it. All right, I'm going to go a little bit faster now because I need to allow some time for Errol to talk to us about his use case. I'm going to focus a little bit on the management side. So when we're saying fully managed, what exactly do we need? I don't need to do anything, or is there something more to it? So we see the fully managed, or the ease of use, if you will, in 3 different ways. The first one is that it's fully managed, so if you don't want to do anything, you don't have to do anything. So we're going to take backups for you, we're going to figure out how to organize your data, and so on, in a default way. But we're also focusing on the automatic optimizations. So looking at your workload, we're trying to organize the data differently in order to benefit your workload without you needing to do something explicit. And the last one is that if you really want to customize it and you know your use case much better than the system can, you still have the ability to do so. So let me get into a few more details of what I mean by these. So the first one is the auto vacuum, auto analyze, auto table sort. This is the fully managed aspect. So what we have done here is that you don't have to execute analyze anymore. We automatically go and gather statistics. We update the statistics. We make sure that the query plans that we're generating are the good ones based on our cost model. And of course, we do this incrementally. We do this when the cluster has pair cycles and without intruding into your workload. We did the same thing for automatic vacuum delete, where we go and reclaim the space as you are deleting data. And we also did the automatic table sort. This is the most recent announcement, which I'll talk a little bit more in the next slide. We also have the automatic table distribution style, meaning that when you're creating a table, we automatically distribute it everywhere because it's small, meaning empty. And then as you are ingesting data into the table, beyond a certain threshold, we will on the fly convert the table from distributed everywhere to distributed evenly everywhere. So distributed evenly, and without you having to act on it, right? And we do that mid-transaction. We're also having the distribution and sort key advisors, meaning that we observe your workload, we're figuring out based on the workload which distribution and sort keys will benefit your workload, and you can choose to do so. Let's dive deep a little bit into the automatic table sort. It's a quite sophisticated way of doing this for the following reason. As you can imagine, fact tables, especially now with the managed storage, the fact tables can get really big. So we don't have the option, of course, to automatically, to sort the entire table, like ever. So how do you deal with it, right? So what we're doing is that within the table, we're trying to figure out the sections that are becoming hot, and then we isolate these ranges that are being asked the most by queries, and then we sort only these regions within a table. We never sort the entire table, right? So, and we do that on the fly as well, and incrementally. So you don't have to sort really your table manually anymore or in its entirety, and you get the benefit, performance benefit, without having to sort the whole thing. So, and this is intelligent in the sense that we don't create homogeneous partitions. Doesn't mean that, all of a sudden we partition by month blindly. Because, let's say that June, July, August might be one range because they are slow months for a particular business. And then September becomes really hot because everybody cares about September. This is when we're back to school and we're buying more items and so on and so forth. So we will recognize this particular month, isolate it from the rest, and merge and sort it. So you get the most benefit out of it. Okay. The next one, briefly I'll discuss about the management console. We have a brand new, very nice looking console where you can actually see in more detail what your cluster is doing. And you can also use the query editor for non-admin users in order to execute queries against your database easily and visualize them as well. I'm going to run very quickly over the query priorities. This is also a very nice feature in the sense that with query priorities now, you can say that a particular set of queries is more important than others. And this is a very nice way of actually maximizing the utilization of the hardware that you're paying for. Because let's say that my queries are more important than yours, but if I am not using my slots, if I haven't submitted any queries, then you can go ahead and use the resources that I would have been using. So no resources are wasted. There is no static separation of resources based on priorities. And of course, while lower priority queries occupy the entire cluster or all of the resources, and then all of a sudden the higher priority queries show up, then we make space for the more important queries. And if we cannot do that fast enough, we're going to preempt queries. Okay? But this is really important in order to maximize both performance as well as throughput. And the system also intelligently, based on automatic workload management, will figure out how many resources, how much memory a query might need based on the shape of the plan, and allocate the corresponding memory. All right. So very quickly, store procedures. This is also a feature that has to do with the migration of existing systems into the cloud. We're speaking the PL PG-SQL dialect. And this feature has, as you can imagine, really very high adoption since it was released. And this is the last slide I'm going to flash one more time for you to look at the rest of the features and dig a little bit deeper. So I skipped over the elastic resize scheduler, where it can optimize your cost by sizing the cluster up and down at certain times during the day. The cross-instance restore that will help you migrate DS2 8XL clusters to RA3, the new instance, in minutes. We have much faster cross-regional copy for disaster recovery, deferred maintenance, and elastic resize. So with that, I will leave you, and I'll ask Errol to come on stage in order to present the Data as a Service product at Workday.
Thank you, Mealis. Hello, everyone. My name is Errol Güney. I've been at Workday a little over 5 years now. So we at Workday deliver cloud-based financial and human resources applications. Particularly, I really enjoy working cross-functional teams, designing coding, delivering, and seeing customers use our applications day to day, and do it all over again with challenging work. Today, I would like you to take away 2 points from my presentation. One of them is understand the Workday's data as a service vision and strategy. And secondly, and more pertinent to today's session, is learn how Amazon Redshift powered our design goals and empowered our Workday data as a service team to deliver and focus on our business objectives. Today, I might be talking about forward-facing statements, and at Workday, we encourage our Workday customers to make their purchasing decisions based on the currently available features and functions. Let's go over how Workday Data as a Service started. Workday has an annual customer conference. We call it Workday Rising, typically around September, October each year. And some of you may have been at that conference if you are a Workday customer. Here in 2016 Workday Rising, my company executive went onto stage and announced that Workday will unveil a data as a service offering, and benchmarking will be the first service for that. Benchmarking service will let the customers to pick the metrics that they like to contribute, and in return, gain access to insights for those benchmarks across their peer groups. After the Workday Rising event, we interviewed several of our executives and came up with 2 high-level business goals for the product. One of them was that all Workday customers should be able to use these services inside their Workday tenant natively. And second business goal was that the Workday customers would have to contribute their de-identified data to be able to get insights for the same metrics. We call that give to get model. In Workday, we try to follow a culture of delivering on our announcements by the next Workday Rising. Here in Workday Rising 2017, we have delivered Workday Benchmarking. And on the left, you can see our company CEO, Anil Bushre, talking to Kramer on the Mad Money show, talking about the Workday Data as a Service and benchmarking product. And on that day, we not only delivered a platform and a service, we've also signed up 100+ customers in less than a year. Just to give a comparison, today we have enough customers to represent 100+ country and produce benchmarks for them. So let's take a look at what it looks like. Here, if you're an HR administrator, you might run this report to get insights in your industry and compare your own company's turnover to an industry peer group. And if you are an administrator again, you might run a more broader benchmark report that gives you more diversity benchmarks, and also build visualization for all your benchmark quantiles, and have side-by-side comparisons with your company's values. So let's take a look at how we did it. Let me introduce you to my mentor. Mark Twain has famously said, "The secret of getting ahead is getting started." For me, what this means is you have to take your complex, overwhelming business goals and break them into must-have tasks and start working on them one at a time. So let's take a look at what are our must-have architectural tasks. So we had to have global data architecture. That is because Workday has more than 10 data centers across the world. For a service like this, in order to be able to compare your company benchmarks with that of industry groups across the world, it had to be a global storage and architecture. It also had to have security from the beginning with transport layer and encryption at rest. We also had to address all privacy concerns because this was a true global service. We had to learn about the GDPR requirements, country-level compliance requirements, legal agreements, and opt-in services. I also had architectural flexibility as a must-have. That is because this was a very infant product, and I needed to be able to adapt based on the customer feedback. So only build complexity when and if needed. And of course, since this was such a global product, it had to have common taxonomy across all tenants. So let's see how Amazon Redshift met the design goals of our Daas. I mentioned architectural must-have. Let's try to map them to solutions. So one of the architectural must-haves I had was a scalable, secure global storage. That meets Workday's SLA. That is Amazon KMS and Amazon S3. We also needed the ability to programmatically evolve both the schema and the data at the same time. That required read after write DB consistency. On top of that, we needed a single master federated storage and database. That is because for our North American customers, European customers, Asian customers, or African customers, we would like to release the benchmarks at the same time. We also had the requirement that the customers could opt in at any time without talking to any Workday support or an employee. That meant that we needed the ability to process large number of files that we could not have had time to predict. On top of that, we needed advanced analytical query capabilities with arbitrary dimensional data sets, with window slicing, partitioning, and Amazon Redshift was the single solution at that point with elasticity that was required for our platform. Here I like to show a high-level diagram of our data flow. And here the Workday Cloud is talking to our Daas backend using the microservices architecture. Since the 2007 announcement of delivering it, we've also enabled external data sets on the platform. Today, we have the following data sets on the Daas platform. On the first release, we released the platform itself. We also released the benchmarking service that sits on top of the customer-contributed data. Since then, we have enabled the public data sets. US Census Bureau is one of the examples, and we are trying to add more countries as we go through. We are also actively partnering with additional data providers to bring data exchange on our platform. Let's have a look at one of the public data sets that we have in production. Here's a US labor market data set that customers could get it today in production. And perhaps more entertaining one of them is occupation by geographic location. As you can see, we can bring so much more data to the platform. To be able to bring all these data sets to the platform, we need elastic scalability, not only compute, but storage. So this really pertains to today's announcement that in order to be able to scale the compute and storage separately is very critical to our platform. With that, I'd like to review the Workday's data as a service offerings and what is next for us. So we have delivered the benchmarking service. We have then delivered the external data sets. We are actively working on machine learning use cases and what we name in-context use case. This is a particularly important concept for us. You can visualize a case where a worker submitting their time of event and a benchmark right next to their page that shows them an average time of event taken by a similar worker in the similar geographic area. And keep in mind that Workday Cloud represents 40 million active workers. So if all customers opt into this solution, we cannot predict the load, and we do not want to scale for the max use case. Therefore, we need the compute scalability as we need it. Another in-context interesting use case is that imagine you're submitting an expense report and you can get a benchmark that represents the median price paid for the same hotel or same trip that you're just taking and paying for through your expense report. On top of that, we like to bring partners and have them self-service enable themselves onto the platform. For those two use cases, today's announcements are really critical for us so that we can separate the storage and compute and scale them independently. With that, I would like to give it back to Mihalis to speak about the related sessions for our talks. Thank you.
Thanks again for coming today. We're listing some of the related sessions around Redshift. We have a lot of child talks and other workshops that digging deeper and hands-on experience with most of the features that I presented. So please attend them. Also, you can visit us at the booth as well. So thanks again. I'm Michalis, and this was Errol. And please remember to complete the survey for our sessions. Thank you.